Afternoon, everyone. This is Ahmed Morsi. I'm a software engineer. I'm going to speak today on microservices and machine learning with .NET 5. First, as a small introduction about myself, I'm an Azure solution architect, certified with more than 10 years of experience in software engineering, design, and development. I'm currently working with ABB as a Microsoft Azure specialist and .NET engineer. I am also a DevOps expert and an Azure developer. And I have a blog called emulike.net. Always I share a lot of information about trendings and some coding and challenges. And this is my social media links. Topics to be covered today. This lecture is going to cover a lot of areas, actually, that all developers or most of developers need to know and to follow these days. I will start by what is how to build a microservice in .NET and how to secure your microservice, how to build machine learning also with .NET, how microservices can communicate each other, what is a RabbitMQ, how to stream data to clients or live data to the clients using SignalR, and how to build a front end for our application, which is using a Vue framework, and more. All of this in this lecture. So, as you saw, a lot of ideas, a lot of areas. So, what is the best idea that I can use and develop to cover all those areas? And this is what I found after having like 2 weeks thinking about. This is an application which is here and hosted and sorry, not hosted, published on GitHub. So this is my GitHub account, Iramax, and the path of the repo is crypto predictor. This application I will cover everything related to this application in this lecture. This is a video for our application. So when you start the application, you will see this screen, home screen, and you can select a currency, and you can select the time frame, and you can change, as you can see, some indicators. And what is new is forecasting. You can forecast. So the forecasting coming from machine learning in .NET, and I will let you know how I did this. And this is a Vue.js application, and we are here using the transit, CSS transit, and here we are using some libraries to show the chart. And if you look into the price is changes. It is changing, so it is a real-time data are arriving and fetched and redraw the chart again. Let's start. So at the beginning, I need to explain some definitions, like what is a microservice. Microservice is a small service which is always has a narrow focused capability, only single goal, a small goal. You need to look into this goal and focus on it. And microservice could expose and an API to the rest of the system, or could be isolated but only working on the service bus or queues or whatever. And we will try to find how the two kind of microservice, which is the active, the asynchronous, or the asynchronous microservice, are working in this example. Also, the characteristic of the microservice is single responsibility for capability, always single responsibility, individually deployable. As I said, the microservice is a small part of your system, and you should build the microservice to be deployable individually and the system discover it and try to send requests toward it. Also, microservice itself always or usually it is a process, but it could be multiple processes running on the same container. Usually also the microservice has its own database or files or whatever, but also it can share a database with other microservices. Replaceable, as I said, microservice is deployable individually, but you can replace it with a new version, with another version which has some upgrades, and this is make your application and system are upgradable without having to fail or down your system. Of course, the most important point is it can be maintained by small teams. So each team can focus only on a small part of on a number of microservices, which is domain expert. They have the domain knowledge on it or something like this. And to cover the application I just spoke about, we have this process diagram. So the user start, open the front-end application, which is the Vue application, Vue.js application, and then the Vue application called the API gateway, and we will go through all those components this lecture. And the API gateway has a connection with all the services. So it has a connection with something called Notify Hub, which is used to manage the real-time data to the client. We also have a connection to the authentication microservice, which is managing the security of our platform and microservices. We have also the prediction service, which is a controller for all the prediction tasks. Also historical data, which is manage how we can collect the data for the chart itself. We will go through all those one by one. So let's start. Usually we start by the API gateway. This is the first layer in your backend. So what is the API gateway? API gateway exposes list of endpoints to the client to allow the client to reach all microservices behind the API gateway. So imagine you have like 100 or 10 microservices. You don't have to list all those microservices in your front end. So if you do so, you are coupling your front end with your backend microservices, domains or URLs. But you can manage this by having a router, which is the API gateway. This gateway help you to reach a specific microservices, and it is dynamically configurable. So in the future, if I want to make API test, so I can switch between the microservice and then send some requests, like 10% of the requests to a specific microservice, and the last 90% to another microservice. Yeah, I can do this. The API gateway help you to manage a lot of things. One of the main things is to terminate the HTTPS. We no longer need SSL between the microservice itself. So when you call the API gateway, you always send an encrypted request through SSL. But then API gateway, when it route your requests, it terminates the SSL and only use HTTP only. One of the main things is to validate the authentication. We need to make sure the authentication is applied on all your services. So when you make the first layer in your microservices system secured, all what is behind it is secured. So we have authentication microservice, and we have the API gateway, which is make sure all your system are secured. And we also can enable caching. Caching, something which is you don't have to manage the caching in your system, in your microservice. No, we can, in configuration in the API gateway, configure the caching. The retry policy, yes, sometimes or always we have some microservice which is very busy and not responding. So by enabling retry policy, we are enabling the system to be retry policy always and always. Enable circuit breaker. Circuit breaker is a good concept, which is when you send a request to a microservice which is unavailable right now, and you don't have to still send a lot of requests always to it. No, we have to open the circuit, so no more requests for like 1 minute until this service become available. Usually this API gateway could be configured by web page or JSON configuration. And we here are using Ocelot. Ocelot is a good API gateway built by .NET and for .NET developers. So I covered most of this. We are not coupling the front end with the back end, and we are securing the system. This is the Ocelot, which is we spoke about, and it has a lot of capabilities, more than what we need. But let's move to the implementation of the API gateway. This is an example for .NET 5. I will not go in details with the code today. The code is already published on GitHub, and the code is very small code lines. Even I noticed that the front end code lines are more than the .NET code for whole this system. And imagine this: it includes machine learning, it includes everything, SignalR, a lot of 8 microservices, but the JavaScript code are more than the .NET code. So for .NET, you no longer need to have a namespace and class and main method. You can start and writing it, your code, like Python and all the other scripting languages. So you don't have to have this structure. The Visual Studio or the language itself will cover it and will convert your code into that classes, but you don't have to write and make your code has a lot of parentheses and so on. And this is why the code is reduced rapidly. And most of the code are like 10 or 15 lines, not that much for each microservice. And this is why you can build microservices right now in .NET with viewer line of codes. By this, I can move to the next microservice, which is Notify Hub. Notify Hub, what it does, Notify Hub? It enables client to stay connected with your stream. So you have a stream on your server side, and the client, or you have like 100 clients connected. You want to publish the stream of data. What kind of data I can publish to that? The ticks, the changes in the price of your cryptocurrency. So we are here speaking about Bitcoin, Ethereum, or whatever cryptocurrencies we support. So you want to send the changes in this cryptocurrency and on this time frame. So this is why we need the Notify Hub microservice. It is mainly a SignalR hub server. So it enables another ticker server, another ticker microservice to broadcast the changes. and I will cover this in details in a few minutes. So every client is connected to the SignalR hub, and the client subscribe to the active currency and time frame. The ticker server on service on the other hand, on the other side, is connected to the SignalR and publishing a new text. So when the ticker publish the text, the changes in the price, the SignalR broadcast those messages to all the subscriber, and this is what we will see right now. To go with a definition of what is a SignalR. SignalR is a library from Microsoft. It has been maybe 10 years right now. It uses WebSocket, which is very efficient to manage sockets through clients and to publish real data to your clients' web applications. And it could be used to make like chat rooms or stream broadcasting, whatever WebSocket used. In the same time, you can execute a remote procedure in the other side. So from the SignalR server, you can ask the client to execute a specific method, and in the same time, from the client side, you can ask the SignalR to execute another method. By this, I can also speak about the code. The code is very low, and we are here defining the main application, the listener, and this is the SignalR server hub. This is a view lines of code, and this is the service. If I am going also to speak about historical data, when we started to look into the video in the beginning of the lecture, we saw, and to go back to update you again, when the chart start, usually it loads some data. You load some data and then load the new updated data, the new changes. So we have a historical data should be loaded at the beginning, and we have to subscribe to the new changes, which is always in the last bar. Then last bar, and I can go back again. So historical data microservice is used to bring you to provide the historical data for a specific currency on a specific time frame. We are here using Binance API. Binance is a provider. I will cover this right now in the next slide. Nugget packages we are using is Binance.net. And what is Binance? Binance is a cryptocurrency exchange, provide a lot of cryptocurrency trading platform. Right now it is the largest in the cryptocurrency exchange, and it provides an API for free. So everyone want to run this application, please make an account in Binance and generate an access token for your application and use it. Before going depths, let me also speak about what is a candlestick is. Always when you want to show the price changes, we don't show the ticks. We show the price change per time, per interval. So for example, 1 hour for this from 11 to 12, how the price changes. It changed. So it could be started, which is we call it opened, the open price, and the close price, which is at the last second of this hour, how the price was, and the high price, which is the highest price has been reached, which is here are the shadow, and the lowest price. This is how we interpret the chart and the prices. So with this, I can show you that I'm using a library which is it called Binance.net, and this is the code for it. It managed to how to create a client to load the data for your system and this microservice has a controller, so it exposes an endpoint. Right now it exposes endpoint, and this is endpoints is to collect the data for a specific time frame, for a specific currency on from time to time, from like from yesterday to today or to now. By this I can move also to the ticker microservice. Ticker microservice is a microservice which is also using Binance SignalR server. So Binance SignalR server are a service which is Binance provide to publish a new changes in the prices, and the ticker is subscribing to these changes and then republish those changes into Notify Hub, and from Notify Hub it broadcasts those messages again to the front-end users. Why we don't make a short link between the front-end and Binance SignalR instead of having Notify server and ticker? If we do so, we have to expose our API secret and credentials to the front-end application, and no one wants to do so. So in real time, you have to collect the data from a SignalR server of Binance or whatever the provider, and then broadcast it to your SignalR server and toward your clients. And this is what we explained right now. So it publish all the candlestick changes of all the coins we are support right now. For example, 2 coins, the Ethereum and Bitcoin, on all time frames except the weekly one. And we connect to Binance Hub and subscribe to those time frames and currencies and republish those messages we are getting. We are here using a SignalR client and configuration to fetch the secrets. And this is the code for it. As you can see here, this service doesn't expose any endpoint at all. So it is isolated, only connected with the system by the SignalR hub, the Notify hub. So it is isolated from the system. It doesn't expose anything. You are not able to connect with this microservice at all. With this, I can move to how we build a lot of microservices right now, how we can authenticate and secure these services, how we can manage authentication. As you saw before, all the microservices code was like 10-15 lines, but this is authentication is isolated. So if we didn't have this one, we had to have its code on all the other microservices, and will break our knowledge about microservice, which should be single responsibility. So authentication service, it exposes an endpoint. So first it has an endpoint to the client. The client can use this endpoint to log in. So the username, the client has a username and password, and when it sends this username and password, it gets a token. Then it uses this token when the client connect to other microservices. And by this, we need to say something, which is the front end. We have seen right now didn't looks like it has an input for username and password, but it has this credential hard coded in the code. But in real time, in real examples, you can have a username and password and login process and so on. So, and we will look into this in the client side part. So usually the user log in through this endpoint and get a token and use this token for future. If the username and password was invalid, he will get unauthorized HTTP status, which is going to not let the client continue asking any other microservices like the historical data or SignalR or whatever. And this is the code for it. It has this is the main application for it. I am configuring the dependency injection, and this is the class which authenticate and manage the authentication. And we have two users here, demo and admin and password. And this is the controller, which is using this class we spoke about, and it generates the access token for our client. By this I can move to the prediction service. Prediction service is a controller, is a manager for all prediction requests. So usually you ask, I want to a prediction for this cryptocurrency on this time frame, and when the request comes to this microservice, which is exposing an endpoint, and you will get this endpoint, you can reach this endpoint through API gateway. And when you ask, I want a prediction for this cryptocurrency, it will make a request message which has a payload containing all your requests for prediction, the cryptocurrency, the time frame, and it will send this request to massMQ broker. Here we are using RabbitMQ. When it sends this request, the message broker will create an exchange and queues for this kind of messages. In the same time, we have a predictor are listening and connected to the queues from the massMQ broker. It gets the message, it gets this request, and then resolve this request payload, and then do the machine learning stuff, and then return or republish a response into MQTT broker. Then from the prediction service, catch this response and return it to the client. This could be a lot of stuff. Machine learning service sending to the RabbitMQ, RabbitMQ message get handled by the predictor, and predictor make a lot of machine learning and training model and forecasting engine, and then forecast and then return this forecasting into the prediction, into the MQTT, which is getting handled by the predictor service, and then all this return to the front end, and the front end show you how this prediction looks like. We will speak about this in details also in the front end part, but for here we are using something called massTransit. massTransit is a good tool which is very useful to build such communication between microservices. And by this I can also speak about what is RabbitMQ. Always when we want microservices connect each other, we can have a service bus, Microsoft Azure service bus, or it could use queues, or it could use RabbitMQ. Another approach, MQTT, which is another telemetry protocol, small and lightweight from MQ protocol. So here I'm using RabbitMQ installed in my system, and this is a massTransit. The massTransit is a .NET based enterprise service bus software. It helps you to manage all such requests and responses without having to label your messages and control your threading and so on. It also being used to manage CQRS and retry and versioning and Saga patterns as well. And this is the main application, the prediction. Always I need to configure that I will send such prediction requests, and which host for the RabbitMQ. And this is my endpoint, which is the controller, and I'm here using from services to inject my iRequest client. The code is, as you can see here, is very short and less line of code. By this I can also speak about what is the predictor. The predictor is a machine learning algorithm which is using a time series forecasting algorithm. ML support ML.NET, which is the main library behind this machine learning. Usually most of your .NET developers use ML.NET. ML.NET has covered a lot of libraries and a lot of algorithms, and we will speak about this on the next slide. So as I said, the forecasting this predictor are try to predict the next 20 candlestick. Always it gets a request and try to train the model and then generate a time series forecasting engine and then publish the prediction result. It uses massTransit, it uses RabbitMQ and ML time series. By this I can speak of what is ML.NET. ML.NET is a Microsoft version for machine learning framework for .NET developer. It has a lot of capabilities right now. It can cover a lot of range of applications for machine learning, like price prediction, product recommendation, sales forecasting, image classification, and object detection, and more and more and more. They have hundreds of samples and examples online. So usually when we need to have a machine learning, this is the way we need to build our machine learning application. We need to collect the data first, then clean the data. Yes, we need to collect and clean the data. Then load the data and extract the features. This is the preparation of the data. After extracting the features, we need to build and train the model. Usually we need to select the model and how the parameters for it, and then use our data to be trained with this model, and then we need to execute this model. On a specific price prediction. So we need to ask, please predict the next 20 candlestick. By this we are getting the data. Always we can repeat the build and train and execute. So we can use the same model. If we save this model, we can always train and predict with the same model. And if I'm going to speak about this application, this machine learning application, as I said, it starts by fetching the data. So we need to listen to the queue of getting a request for prediction, and this is the code for it. When we handle the request, this is a consumer which is going to handle the request and manage it, and it does fetch the data and forecast. As you can see here, we are fetching the data for this message arrived, for this request. So in this fetch method, I'm going to fetch the historical data for this currency and this time frame from another microservice, which is, we said we have a microservice called historical data. So the predictor contact with historical data microservice, asking for give me the last 20 candlestick for this currency and this time frame. Usually between microservices, we are not going we don't need to call the API gateway at all. We can call the microservice directly, and this is better because we don't want to go with SSL or such stuff. In the same time, this is when we got the data, we need to train the data. We need the forecasting. What is the machine learning ML.NET can do for us? This is the machine learning code. Only this lines, around 15 lines of code. It does machine learning. So we are here configuring the parameters of our model, and after I have played with the parameters, I found these parameters are good enough for our example. So we are trying to make what is how many series we have in this data, how many the series window or the window for our data, and what is how many bar we want to predict. This is 20, and confidence level. We will have also an option to have a boundaries for our prediction, so we can have like 75% confidence level. Of course, the more it is tight is better, not the wider is good enough. We are here creating ML context, and we are creating a data view, load our data which has arrived from the historical data. We are here creating a pipeline for our model. So we are speaking like we need forecasting for forecasting model, and we will forecast the close value in the input, but our prediction going to use the prediction result value, and we are giving the parameters we have added, and which is the parameter could handle the lower and higher, and we then train the model. This is the line training the model, which is model equal pipeline.fit for our data, and this is creating the time series engine and so on. This is how we manage to build machine learning algorithm. Last thing I can speak about what is the front end microservice we have. We have a front end which is cover a lot of kind of services: login, fetch the historical data, render the historical data, and load the forecasting. And this is a Vue single page application and single SignalR connection. So I'm here using Vue.js. It is very popular, and I totally motivate this approach. And also I use Tailwind Css, which is a very amazing library for CSS. All this application didn't need me to write any CSS line because of this library, so I always motivate to use this library. And this library has different classes. Sorry, this client has different classes to manage as a request, like getting access token at the beginning, and then load data, load forecasting, and connect to the SignalR server, and subscribe to a specific signal currency and time frame, and unsubscribe when you change the time frame. I do unsubscribe, and then when you move to another time frame, I subscribe to the new time frame. And this is the main application. It has a component above, but it has this is a mounted method, which is loading the chart and loading the forecasting and loading the start the subscription. By this, I can end the speak by what lesson learned. In my side, I learned that .NET 5 helps you to develop microservices very easily. Binance and many other cryptocurrencies provide free and public APIs to get data feeds, and this is a good way to make your machine learning algorithms. massTransit is a breakthrough into microservice, and I guess it is very important for any microservices developer to use it. Machine learning, nothing I guess as simple as this the example. We can have a machine learning easily. Vue.js is a very helpful in building a good front-end application with less code. And SignalR is a good tool which is very easy to use in your system to make a real communication between you and the client. And before ending this, I can also running the application and let you see how the application is up and running. So I will start the application now. As you can see here, I have a lot of microservices are starting, and this is the front end is running. Oh, maybe it is closed, sorry. Yeah, this is the main application. This is the main menu, and this is right now it loads the data. If you see here, get access token, load data, load forecasting, and then it will start the subscription. Yeah, this is the SignalR started, subscription started. So we can move to another time frame. As you can see, prices are changing, and if I click here, this is the forecasting for this this currency on this time frame, and this is some another indicators. And thank you everyone.